In this session, you will learn about the art of scientific writing. You will experience to clearly articulate your research, embed it into existing literature, and follow established citation rules. In science, knowledge isn't real progress until it's shared. You write scientific publications to communicate your findings so others can learn from them, use them, or challenge them. You will practice that in this seminar, in your bachelor thesis, and perhaps later, even more in a potential master and PhD thesis. Publishing also invites peer review. That's how others validate your work and make sure your methods, reasoning, and results stand up to scrutiny. This is how you can add to the collective body of knowledge so that science can advance one careful step at a time. Detailed publications allow others to reproduce your experiments and verify your claims. Publications also give you credit for your discoveries, building your professional reputation and providing your expertise. For researchers, publications are currency. They are required for funding, promotions, and career growth. And by making our work public, you open the door to collaboration with others around the world. In short, you publish so your work can become a part of the scientific conversation, transparent, testable, and impactful. When it comes to structuring a scientific paper, the INRED format, introduction, methods, results, and discussion, is the gold standard in academic writing. It's not just a tradition, it's a structure designed for clarity and transparency. In the introduction, you set the stage, outline the problem, explain why it matters, and state your research question or hypothesis. Then, the methods section details exactly how the research was carried out, allowing others to reproduce or validate your work. Next, the results section presents your findings, often supported by figures, tables, and statistics, but without interpretation. Finally, the discussion interprets those results, explains their significance, connects them to existing literature, and outlines possible future work. INRED helps ensure your paper is easy to follow, easy to review, and easy to build upon, which is exactly what good science needs. A well-written scientific paper or thesis has an internal symmetry. What you open, you must close. Points raised in the introduction should be addressed again in the conclusions, so the reader sees how your research journey answered the questions you started with. The literature review sets up what's known and unknown, and those same themes should reappear in your findings or reflections, showing that exactly how your work connects to or challenges previous studies. And finally, whatever you describe in your methods or design must be mirrored in your development or experiment chapter, so the reader can clearly see that your research plan was carried through in practice. This mirroring helps you building a coherent, logical narrative where every promise made early is fulfilled by the end. Before you can make meaningful progress in research, you need to know the state of the art. What has already been discovered, what methods have been tried, and what gaps remain. This is what we mean by standing on the shoulders of giants, building on the understanding gained by the major thinkers who came before you, so your work can move the field forward. The literature review is how you do this. It lets you discover and understand how others have tackled similar problems, the results they obtained, the shortcomings they observed, and the methodologies they used. By reviewing the literature, you familiar readers with related studies, place your work in context, outline the gaps your paper fills, establish the significance of your contribution, and provide a basis for comparing your results with previous findings. A strong literature review balances breadth and depth. The breadth of your review sets the scene. It describes the foundational research across the different areas of your domain and giving a wide overview of the landscape. The depth focuses on the particular topic your research builds upon, examining the key studies in detail. Ideally, your review should cover roughly the same number of research papers in both breadth and depth providing a comprehensive yet focused foundation of your work. When conducting a literature review, it helps to divide the process into 3 parts. First, you identify and acquire relevant research sources. This can include journal papers, conference papers, textbooks, theses, websites, and more to get a comprehensive overview of the work that has already been done in your area. As you collect these sources, make sure to record them and summarize the relevance. Focus first on papers that closely relate to your research, then broaden your search as needed. Second, maintain a list of keywords that describe your research and update it as you read more papers and discuss ideas. Credibility is crucial, so search in established archives and databases is essential. Using your keywords, look for sources online and offline, journals, conferences, textbooks, company white papers, reputable websites, and even blogs or wikis if they add context. Remember, using Google is not enough. A thorough literature review combines multiple credible sources to build a solid foundation for your research. Third, when building your understanding of the literature, there's no hard rule on how many papers to read, but a practical approach is to collect a substantial number, let's say around 30, and then divide them into piles based on subtopics within your research. Some papers will cover the overall theme, while others will focus on specific issues. Organize your reading into manageable sittings, for example, 5 papers at a time, and take careful notes on approaches, terminology, and useful examples. As you read more papers, you will notice fewer new terms, and your expertise in the field will grow. Continuously update your list of keywords based on your reading. Various tools, like Mendeley, can help you to stay organized. Finally, don't hesitate to discuss your findings or ask for guidance, such as consulting your supervisor or peers. This interaction helps refine your understanding and ensures you are on the right track. The key goal of a literature review is to identify the gap in existing literature and show how your work will address it. Your task is to distill a coherent narrative of the research to date, one that naturally points towards the gap your study intends to fill. For each article you consider, ask yourself, is this significant enough to include in the review? How do I evaluate this significance? Does it help build towards the research gap I'm identifying? If I remove this article, would it change the story I'm telling? Finally, group articles into research trends so the review highlights the major directions in the field and clearly positions your work as a meaningful next step. When writing your literature review, think of it in 3 main sections. The beginning or introduction should introduce your main research topics and provide definitions for key concepts, especially those that support the approach you will take in your research. The middle section discusses the main research trends, identifies key researchers, and guides the reader through the evolution of the field toward the research gap your study will fill. The conclusion summarizes that while much work has been done in the area, a clear gap exists, one that your research is designed to address. As you conduct your review, feel free to use these practical guiding questions as presented on this slide. When reviewing a paper, ask yourself 3 things. What kind of article is it, and what problem does it address? Does it contribute knowledge you can use, and how does it compare with similar work? And finally, are the methods, results, and discussions clear and reliable? On this slide, you'll find even more detailed questions that help you decide whether the paper truly strengthens your literature review. Citations are the backbone of scientific writing. They show where your ideas come from, give credit to the original authors, and allow readers to verify and follow up on your sources. Proper citation is not just about avoiding plagiarism. It also demonstrates the depth of your research, situates your work within the existing body of knowledge, so others can see your relation to existing knowledge, which in the end strengthens the credibility of your arguments. Obviously, not every fact needs a citation. Common knowledge, facts widely known and undisputed, like the Earth orbits the Sun, does not require a reference. The same goes for basic knowledge in your field, fundamental concepts your audience is expected to know, like binary numbers are used in computer systems for computer science students. There are many citation styles, and different fields and journals may require different formats. Some of the most common include APA, widely used in social science, emphasizes author and year. IEEE, common in engineering and computer science, uses numbered references. And MLA, popular in humanities, focuses on author page citations. Chicago, which has flexible styles, often used in history and social science. However, if you use BibTeX in LaTeX, you don't have to manually format each citation. You simply provide the data in a structured format, author, title, year, journal, etc., and the citation style template automatically formats and structures the output for you. This ensures consistency and makes switching between citation styles as simple as changing a setting. Wrapping up, scientific writing isn't just about putting words on paper. It follows a formal structure so readers know exactly where to find each type of information. At its core, good science is about transparency and reproducibility. You describe what you did so clearly that someone else could follow your steps and reach the same results. And finally, your work doesn't exist in a vacuum. By embedding it into literature, you show how it builds on past research, fills a gap, and contributes to the bigger scientific conversation.